Hi there, welcome to Mini Math Lessons with Karen. And today we're looking at two activities that have to do with systems of inequalities. And so I am going to kind of just walk through them briefly, do a little bit of the inequality stuff with you so you kind of understand what's being asked. So I'm in ClassPad.net, free web-based math tool that does pretty much everything. If you don't have an account, I suggest you sign up to create one. You can just create an account right here, because then these activities that I'm sharing with you, which is a URL link, which is in the description of the video. If you like it, you can save it if you have an account, or you can modify it after you saved it. So there's a lot of things you can do if you have an account. So I'm going to just click on the first one, and you'll notice up here, this is the URL that's being shared. It opens up this page. Technically, you're in as a guest when you're working in this situation. But if you have an account, you can duplicate it up in the corner and create your own version. So this is an activity called Fishing Adventures. It was modified from Illustrative Math, which is a free open source curriculum. So I just took a problem from one of theirs. And this is basically about, it gives you some constraints. There's a boat rental place, and they have some limitations on how many people can be in the boat and how much weight. So very realistic. So this describes you can have no more than 8 people. You can only carry 1,200 pounds, and that's people and gear. And then it makes some assumptions that the average person is 150, average child 75, and most people are going to have 200 pounds of gear plus 10 per person. So based on that, they have to come up with some inequalities and start graphing them, right? So they're going to create their inequalities that represent basically the children and the adults. So X is children, Y is adults, and they're going to graph those equations here. So I'm not going to go through all of the work that you might do, but I just want to show you how you would graph your inequalities. And so you'll see the graphs already set up where adults are the X and children are the Y. And so one of the equations has to do with how many adults and children can be on what's the max, right? So one equation would be that adults and children together, so X and Y together, has to be less than or equal to. So to get your, so you notice as the keyboard comes up, to get your less than or equal to, that goes in the math. And so I'm going to do less than or equal to 8. So that's one of the constraints that was up here, right? You can only fit 8 people in a boat. So a combination of adults and children can't be more than 8. So that's one inequality. But now watch what happens when I graph it. It's basically going to shade the region that has a solution. So there's lots of combinations at this point of adults and children that we can put together. And one of the things students are going to have to, keep in mind is that you can't have half a person. So some of these, even though they're technically solutions, they're not going to make any sense. You can't have negative people. So then do we have to maybe limit the domain? And you'll see down here in this, it says, think about that. Do you have to limit the domain? And we probably should limit that. Our X can't be, we basically need to keep it positive, right? So X, actually, let's go back here. X should probably be greater than or equal to, where am I? 0, right? And I should probably also have children. So remember, X and Y represents children and adults. Children should probably also be greater than or equal to 0. So I'm going to put both limitations on here, thinking about the context of the situation, and watch what happens to my graph. So now the feasible region, the place where there's solutions that actually correspond with the number of adults or children, can really only be the positive numbers. That makes sense, right? So we've kind of limited. So these are things that they're going to think about when they're working with this problem. The other one has to do with weight. And remember, each adult's 150, each child is, what am I saying? 75, but then they did add in that constraint that add an additional 10 per person. So really each adult's going to be 160 for weight. Each child's going to be 85 for weight. And then they also said, well, you have to add in 200 pounds because we're going to have other gears. Maybe it's lunch, maybe it's, some other things. So all of that can't weigh more than, so it has to be less than or equal to, and what was it? 1,200 pounds. So that would be our other constraint. So basically you're trying to help them figure out, how do I graph these situations? And again, notice, here's all my possible interesting things. What am I really interested in? I'm interested in just this feasible region. Weight can't be negative either, so I might want to put some limitations in. And I can also, when you go into the settings of the graph, you can, right now we're looking at the union of these two things. We could look at the intersection and see what that brings us. And so that kind of, right here is all our possible solutions. And then the rest of the problem is just, plot a point. So let's just plot a point. I'm going to say 2, looks like it's in my reasonable things. And, whoa, I don't know what happened there. There we go. I don't know why it went so big. It went kind of crazy there. So there's a point in my feasible thing. And what does that actually mean? Well, it means I could have 2 adults, 2 children, and it would fall into the solution. And then they can actually move this around. And what answers, what does each make sense, that type of thing. And then they're going to actually use the graph to answer some questions. So that's the first activity. Second activity is a little different. It actually gives you, oops, go back up here. It gives you an image of a region, right? Here's 4 different regions. These are 2 lines that I've graphed, and then there's 4 different regions. And it basically wants you to then think about, if I only want to see this part of the graph shaded, what inequalities do I need to use? Do I need to do less than, greater than, less than or equal to, greater than or equal to? How do I arrange my equations? And so you'll notice that they have to do it for each region. They have to come up with how they're going to graph that. And so you'll see here, I've already done region A. And then if we wanted to do region B, we're really kind of helping students try to understand. So if this is region B, it's less than this line, and it's greater than this line. So I have 2 different inequalities, whereas in this one, they were both less than. So that was region A, right? This is less than and also less than. So this was less than both. But this one is greater than one and less than the other. So we are helping students try to look at situations, really try to explain, what does that feasible region mean? So they're going to basically create the, and let's actually see if we can do it. Ha. Trying to copy and paste. Oh, doesn't like me to do. There we go. I'm going to copy and paste it because it's the same linear equation each time, but we're deciding, so I think it was greater than this one. So we're going to switch this, and then let's see if we're correct. Yep, looks like we're correct there. And then we're going to do this one. And I think that one is fine the way it is. So basically they have to kind of determine what is the region. So when I hit this, it should give me, yeah, so it gives me region B. So notice all the graphs are already set to just show the intersection. So I should just see that region B, and I can even move this graph up to verify that I actually have, whoops, region B, which I do. So you can see I have region B. So it's basically helping students understand what's greater than, what's less than, what does that actually mean? And so then they're going to explore, after they've found the region, talk about a point in there and explain how they know that that's a solution to both of these. What does that actually mean? So that's more or less explaining and understanding that they understand what the inequalities are actually representing. So have fun exploring those. Those are